last Space and Science Subcommittee hearing of the 117th Congress. Landsat at 50 and the future of U.S. satellite-based Earth observation. I know I have almost never mentioned on this committee, well, I try to mention it fairly frequently, but I am a former geologist, and I've seen firsthand how the dynamic circumstances around our country, our world, how our world is constantly changing, and that ecosystems across the globe in many ways support each other. Oceans affect forests and plains, and we should understand what the phrase surf, turf, and what's above the earth are all crucially interconnected. Observations from space allow us to get to a better understanding of changes in our planet over time. The CHIPS and Science Act reaffirms our nation's commitment to science and to research. Today we're going to examine important scientific missions carried out by important partners in government and academia, the commercial sector, all playing a role and all interconnected. Earth observation provides key data that serve many purposes. Farmers can measure soil moisture to make sure they can improve crop yields. Weather, the National Weather Service forecasts to alert residents of hurricanes and tornadoes. In the case of emissions, we can detect and increasingly measure fugitive emissions, such as methane from oil and gas wells. In terms of Colorado, there are two key issues that we've seen where Earth observation has become increasingly important: wildfire mitigation and drought management. Some would go so far as to describe our droughts in the West now as so prolonged that they don't qualify to be considered droughts. They are aridification or desertification. They are more permanent than generally we think of with a drought. We have an image here of the East Troublesome fire over my right shoulder here. It burned over 190,000 acres, destroyed over 350 homes, caused over $500 million of damage in Colorado. And instruments built by Ball Aerospace, Colorado-based company, we're on the Landsat 8 satellite, captured images of the fire. That one on this far from my right is a natural color showing the smoke plume, but the second uses infrared light to show details of where you have the active fires, bright red, the burn scars are dark red, and the vegetation is green. The second image I put up here as a part of the show and tell is Lake Powell, the second largest reservoir in the entire country, and part of the Colorado River Basin system. This ongoing drought, this aridification, is making water management a top conservation policy. Last fall's emergency release of water helped Lake Powell's hydroelectric power generation, but it was really a stopgap measure. Lake Powell is currently filled to only 26% of its full capacity, the lowest level since 1967. And you see that in frightening clarity in that image. These images from Landsat showed the changing water levels between 1999 and 2021. And by any measure, these are drastic reductions in water levels over a relatively short period of time. With today's hearing, we look forward to better understanding how our federal, academic, and commercial Earth observation activities can better complement each other, can be better orchestrated. How can we use this data to improve ecosystem conservation or adaptation? And what benefits can emerging technologies like artificial intelligence or cloud computing provide for future Earth observation? Today's witnesses include, well, our array is reminds me of the 1927 New York Yankees, one of the greatest batting orders in the history of baseball. Today's witness panel brings immense expertise. Dr. Steve Volz, Assistant Administrator for Satellite Information Services, and leads NESDIS, NESDIS, I should spell it out, at NOAA. Dr. Kate Calvin, Chief Scientist of NASA. Mr. Daniel Jablonski, who's the CEO of Maxar Technologies, also based in Colorado. Mr. Kevin Gallagher leads the Landsat program at the U.S. Geological Survey. And Dr. Waleed Abdulhadi is the director of CU Boulder's Cooperative Institute for Research in Environmental Sciences, CIRIS, and served as co-chair of the recent Earth Science Decadal Survey. With that, I'll turn it over to Ranking Member Lummis for her opening statements, and then recognize Chair Cantwell and Ranking Member Wicker when they get here.
Well, thank you, Chairman Hickenlooper, and thank you, witnesses, for joining us today. In the West, our land is a key part of our very lives, our every activity, and certainly part of our culture. Whether it's agriculture, energy production, or our parks, Wyoming's land shapes our people, our economy, and both in nearly every way imaginable. Having detailed data on how that land changes over time, how it responds to the changing of the seasons, or how it is impacted by severe weather is extremely valuable and necessary to make informed decisions. That's why I'm glad we're holding this hearing today, so that we can highlight the importance of the Landsat program by showing how it interacts with each of these issues. Through these images, we can better understand how seasonal changes affect crop yields, better insights into previously unknown locations for mineral deposits, and a deeper knowledge of how to prepare for snowmelt across the region. The Landsat program has provided significant resources to individuals and businesses operating in Wyoming, especially since the program moved towards open data for the public. It's my hope that we are able to emphasize the work already underway in the Landsat program and prepare the program as we move into the future. So thank you all for being here, and I'm really looking forward to your testimony and our discussion.
Great. And I don't see, this is one of those moments where we have a lot of, there's a lot of stuff, there are a lot of balls in the air, so I think our chair and our ranking member might be a little late or might become conflicted out. Anyway, I think we can go to, go to our expert witnesses. Dr. Volz, why don't you begin? You're here by video. Since you're on video, you should get special consideration.
So thank you, sir. And I wish I could be there in person, but I'm happy to participate remotely and the opportunity to do so. Good morning, sir, Chair Hickenlooper, Ranking Member Lummis, and members of the subcommittee who are there. As noted, I'm Dr. Steve. I'm the Administrator of NOAA National Environmental Satellite Data and Information Service. It really is an honor to speak to you, along with so many of my close partners, about the anniversary of the Landsat program, of NASA's creation, and of the launch of the TIROS-1 satellite and our own beginnings. We can trace our agency's start in space to the collaborative scientific project known as the International Geophysical Year. That effort in 1957 and 58 spurred satellite development and highlighted the importance of global Earth observations. NOAA was established with a broad mission to study, understand, and support the health of our oceans and atmosphere, and a unique charge to predict how our environment changes and to predict the events of that environment for our people, from hour to hour and from year to year. We save lives, protect property, and enhance the American economy by monitoring and forecasting weather, water, and the climate, and by informing our citizens every day. In that job, we deploy ships and planes, buoys, balloons, drones, and satellites. Satellite observations from NOAA and from our national and international partners account for around 90% by volume of all data used by NOAA's forecast models. and satellites are essential to develop and extend critical planetary climate data records, which allow us to understand the changing planet. But we don't just use satellite data. NOAA defines and designs our nation's environmental satellite system. NASA manages their launch and their construction, and we operate the fleet of satellites over decades. Our three agencies' missions are complementary. NASA develops the space technology and the fundamental understanding of how Earth systems operate. USGS and NOAA track and investigate the causes and consequences of climate change, and NOAA exploits technologies and delivers observations and information that the nation needs every hour of every day. And together, we all develop science-driven models of the Earth and climate system environment to advance our individual missions. And the need for better understanding of those systems is great and growing greater. Our experience with hurricane observations and research has taught us lessons over the years. The better observations, research, and modeling lead to better forecasts and outcomes for our communities in the paths of storms. Improved observations from satellites, aircraft, and other data sources, and better research and data assimilation have led to improved forecasts. Since Hurricane Andrew hit Florida in 1992, we have reduced hurricane tracking error by 75% and improved intensity forecast by 50%. We are facing hurricanes now that are stronger and more frequent than in the past. And we are dealing with more damaging extreme events, including wildfires, as you mentioned, and flooding, occurring year-round and nationwide. We need to be able to precisely forecast fire and flooding events, as well as derechos and ice storms, not hours, but days in advance, in order to inform emergency managers and communities more effectively. We can do that, but we need better observations and better models to do it. NOAA's next generation space architecture is benefiting from the successes of NOAA's geostationary low Earth orbit satellite programs over the years, including different ways of block buying instruments and satellites, better ground systems, and use of commercial data. Our next generation geostationary satellites currently provide only continuous aerial observations in the Western Hemisphere, supporting severe weather and hazardous environmental condition watches and warnings. And the next gen geostationary extended observations, or GeoXO mission, will continue and expand on the current GOES-R series with planned observations through 2055. One of GeoXO's advanced capabilities is something that's called a hyperspectral infrared sounder. This sounder will provide improved real-time information about the vertical distribution of atmospheric temperature and water vapor, and will significantly enhance observations of wind speed and direction. And with these better data, we'll be able to better track storms, predicting the behavior of fire and smoke around wildfires. NOAA's current fleet of low Earth orbit satellites, known as the JPSS series, and including the just launched JPSS-2, provide critical weather data and continuous climate data records. NOAA's future LEO satellites, low Earth orbit, will supplement and eventually replace our current JPSS satellites, providing improved modeling, higher resolution short and long-term weather forecasts, and better preparing the nation for extreme weather and events. And finally, our third leg is our nation's current space weather system. It now includes NOAA observations and NASA and other research missions in extended service life. NOAA's next Space Weather Next will extend these observations and provide operational forecasts, helping safeguard our power grid, civil aviation, and spacecraft and astronauts. Finally, I would note, we know our citizens need weather and environmental information to thrive and not just to survive in a changing world. NOAA and NESIS are not just ready to do this, we were actually created for this mission. So I thank you for your strong and continued support of our programs, and I'm happy to answer your questions. Thank you.
Great. Thank you, Dr. Vols. Now we'll move over to Dr. Calvin.
Thank you. When we look down at Earth from space, we see this amazing, indescribable, beautiful planet. It looks like a living, breathing organism. These are the words of astronaut Ron Garan, who spent 6 months looking down at Earth from the International Space Station in 2011. They capture how inspiring it is to observe the Earth from space. In the years ahead, we will need Earth observations more than ever for science and for inspiration. Earth observations are key to helping society understand and effectively respond to changes in climate, and are increasingly used in a range of societal applications. NASA's launch of the first Landsat satellite in 1972 marked the start of a continuous record of land measurements from space that continues unbroken to this day. Today, NASA operates a fleet of over 24 satellites and instruments on the International Space Station. Earth observations from space are the foundation of much of what we know about our planet as a system. Earth observing satellites like NASA's long-running Terra, Aqua, and Aura satellites, and the more recent GRACE follow-on ICESat-2 and Sentinel-6 microfreilich have measured changes in vegetation, carbon dioxide, the mass of ice sheets, sea level, and much more. Earth observations are also a foundation for a range of applications, including weather prediction, disaster response and recovery, wildfire response, land use planning, water resource monitoring, agricultural support, food security, air quality monitoring, and aviation safety. For example, OpenET is an application that uses publicly available NASA USGS Landsat data to provide information to farmers and ranchers can use to estimate the amount of water being taken up on their fields or used by their crops. And this information gives this water will usually need to be replaced through irrigation or rainfall. So this enables them to use water more efficiently and better plan irrigation. NASA continues to lead by innovating the state-of-the-art in remote sensing technologies and following scientific needs to bring new types of Earth observations into existence. We'll soon launch the Surface Water and Ocean Topography, or SWOT mission, which will improve our understanding of oceans and terrestrial surface waters, including providing the first global survey of water running through rivers and lakes. We're also formulating the Earth System Observatory, a set of satellites, instruments, and missions that, when complete, will provide a more comprehensive view of the planet. When combined with SWOT and PACE missions, the Earth System Observatory will measure all major components of the Earth system, including the human-Earth interface. NASA continues to innovate in measuring and monitoring of greenhouse gases from space, with the carbon dioxide monitoring OCO2 and OCO3 satellites. NASA's EMIT mission has demonstrated the capability of detecting the presence of methane, a potent greenhouse gas. In the data that EMIT has collected since being installed on the International Space Station this July, we have identified more than 50 super emitters globally. NASA also announced earlier this year a new contract for commercial data acquisition with GHGSat, which uses satellites to identify methane emissions. Following in the footsteps of NASA's other commercial data vendors, including Planet, Maxar, and Spire, GHGSat will provide their data to NASA for evaluation to determine the utility for advancing NASA's science and application goals. NASA plays an essential role in supporting the continuity of Earth observations through its expertise in flight programs and integrating innovation into new satellite architectures, partnering with NOAA and USGS. We launched GOES-T and JPSS-2 this year and look forward to GeoXO and the low Earth orbit architectures. Landsat Next is just entering formulation. We also merge interagency and international data to allow the characterization of short-term variability and long-term trends in things like radiation, ozone, and aerosols. As part of a growing emphasis on providing actionable data and information to a broad range of users, NASA is planning to launch an Earth Information Center. This Earth Information Center will provide a wide range of Earth data and information to the public and stakeholders, but the initial focus will be on prototyping capabilities for a greenhouse gas monitoring and information system that will integrate data from a variety of sources with the goal of making greenhouse gas data more accessible and usable to policymakers, researchers, and even students. And as always, we thank you, Congress, for your support of NASA Earth Science. We thank you for the opportunity to share this exciting work we're doing to advance Earth observation and maximize its impact, and we look forward to your questions.
Thank you, Dr. Calvin. Mr. Jablonski.
Chairman Hickenlooper, Ranking Member Lummis, Chair Cantwell, Ranking Member Wicker, and esteemed members of the Subcommittee on Space and Science. Thank you for holding this hearing to discuss the important topic of Earth observation. In honor of 50 years of Landsat, my name is Dan Jablonski, and I'm the President and CEO of Maxar Technologies. I've been a part of the Earth observation industry for just over a decade. And before joining the private sector, I was a surface warfare officer and nuclear engineer in the U.S. Navy. I'm honored to be here today. Maxar, based in Westminster, Colorado, is a leader in commercial Earth intelligence and space technology solutions and a proud, long-standing partner to the U.S. government and the commercial industry. Maxar owns and operates a fleet of very high-resolution Earth observation satellites, and soon we'll be launching WorldView Legion, our next-generation Earth observation satellites, and the first to be built in-house. After the passage of the Land Remote Sensing Policy Act of 1992, we were granted the first commercial Earth observation license, opening the door to the Earth observation industry. Since then, satellite imagery has become integral to everyday life. Earth observation capabilities identify, monitor, and address problems that impact the security and economic well-being of every American. For example, Earth observation data helps with natural disaster relief and recovery. Using imagery from satellites and analytical techniques, we can help forecast potential damage and point on-the-ground response teams to locations efficiently, identifying areas that have been damaged by hurricanes, provide precision 3D mapping to optimize relief efforts, and across vast stretches of public and private lands, help responders identify and fight wildfires. Earth observation applications also unlock commerce and mobility. Geospatial data is the bedrock for many businesses and applications that generate significant value for the economy. For example, Google Maps uses Maxar satellite images to not only help users navigate the world, but also to locate and find their way to local businesses, offices, schools, and all other types of locations. In more recent years, the commercial remote sensing industry has been exploring ways to go beyond the pixel. Machine learning, autonomous change detection, and object identification are helping decision makers get to answers quicker. At Maxar, we're pushing the edge on 3D mapping, taking our images and making them three-dimensional, ushering in a new era of insight, augmented reality, and immersive experiences. Critically, the commercial sector is advancing U.S. leadership in space. Commercial satellites support crucial civil and national security missions. As we look to the future of our industry, we must also look to space sustainability. I thank Senators Hickenlooper, Lummis, Cantwell, and Wicker for introducing the Orbits Act, a great step in protecting and maintaining a sustainable space environment for the future. I support this effort and look forward to working with you to find new commercial solutions to solve today's most challenging problems. Maxar stands ready to do its part to help build a sustainable space environment and usher in the next 50 years of Earth observation advancements. Thank you to the subcommittee for holding this hearing and the opportunity to speak to you on this important topic. I'm happy to answer any questions you have at this time.
Thank you, Mr. Jablonski. And with the proviso that for part of my professional life, I wanted to be in the U.S. Geological Survey. Mr. Gallagher.
And we would certainly welcome you. Chairman Hickenlooper, Ranking Member Lummis, members of the subcommittee and committee, I'm pleased to testify before you today during such a dynamic and innovative time in Earth observation science. On behalf of the U.S. Geological Survey, I would like to recognize and express our appreciation for the support that we have received from Congress over many years for our role in Earth observation and mapping, and in particular, Senate Resolution 721 celebrating the 50th anniversary of Landsat and its unique contributions to the nation. Thank you. The Department of the Interior and the USGS have a long history of providing observations of the Earth, including its topography, biology, geological and water resources, and natural hazards such as earthquakes, volcanoes, wildfires, and coastal change. The USGS has been involved in the Landsat program since the late 1960s, when the Department of the Interior charted a bold vision for the use of space technology to sustainably manage the Earth's natural resources. The unique data from Landsat enables scientists and analysts around the globe to detect, measure, map, and monitor critical changes on Earth. Local, tribal, state, and federal agencies all rely upon Landsat data and products to help them understand ongoing changes to their lands, surface waters, coastlines, ecosystems, and natural resources. In fact, Landsat is the most widely used land remote sensing data within the federal agencies, and it's the most frequently cited land data set in peer-reviewed science literature. Landsat data provide enormous economic benefits in the U.S. and around the world, far surpassing the government's investment in the Landsat satellites. In the U.S. alone, Landsat is estimated to provide over $2 billion in annual economic benefits and has been a vital component of the training curriculum for generations of American scientists. Two unique attributes make Landsat the gold standard for all civil and commercial land imaging: the accuracy and precision of the data, and the long and unbroken record of the data. Landsat data is incredibly versatile, supporting applications across the nation for agriculture monitoring and forecasting, water resource management, forest health and productivity, and wildfire mapping and remediation. In fact, the Office of Science and Technology Policy led Earth observation assessments done in 2012 and 2016 ranked Landsat's impact across societal benefit areas as second only to the Global Positioning System. Much like GPS, weather data, Landsat data is a public utility used daily to help us better understand and sustainably manage our dynamic planet. In recognition of the significant cross-government impact of Landsat, the DOI and NASA established the Joint Sustainable Land Imaging Program in 2016 to provide a long-term commitment to historically compatible Landsat observations. This has been, by all accounts, a highly successful partnership. Within the SLI program, NASA is responsible for satellite development and launch, and the USGS provides ground system development and flight data operations, which are conducted at the USGS Earth Resources Observation and Science Center in Sioux Falls, South Dakota. In September 2021, NASA launched Landsat 9, the first mission in the SLI partnership. Landsat 9 has been amazingly successful, working in tandem with Landsat 8 to deliver highly calibrated multispectral imagery, greater than the landmass of North America and South America combined every day. The follow-on SLI mission, called Landsat Next, will be far more capable than Landsat 9, meeting users' evolving needs for improved spectral, spatial, and temporal resolution, critical to identifying and characterizing land surface in areas like urban areas, agricultural, coastal, the cryosphere, and lands increasingly impacted by drought and wildfire. Landsat has experienced a remarkable surge in popularity and continued relevance. In 2022, the USGS fulfilled more Landsat data access requests, at last count more than 4 billion, than in the entire previous 49-year history of the program. That demand for Landsat data is linked to its global utility, free and open access in the cloud, and most importantly, the program's unrelenting commitment to maintaining the accuracy and precision of the data. The SLI Landsat Next mission will ensure that future generations will continue to reap the benefits of the Landsat series of measurements. I'm excited about the future of Landsat and appreciate the opportunity to speak with you today.
Great, thank you. Dr. Abdulati.
Chair Hickenlooper, Ranking Member Lummis, and Chair Cantwell, Ranking Member Wicker, and other members of the committee. Thank you for the opportunity to testify today on the very important matter of the future of U.S. satellite-based Earth observations. I greatly appreciate the work of this committee, and it's also a privilege to be here with representatives from civilian agencies and the private sector who develop and operate and analyze the data for the good of the American people and for the good of the world. Observations from space serve us in many ways, from day-to-day planning to national security to public health to resource management to disaster management and recovery, feeding our people and understanding the threats and challenges and opportunities associated with our changing climate. Some of the benefits are directly derived from the observations themselves. You can just look and see. But many are derived from their integration with models and complementary data. It's that ecosystem of information that's critical, and satellites are a fundamental component of that. Ultimately, however, these observations play a key role in enabling and empowering us to understand what tomorrow will bring. And whether that tomorrow is literally tomorrow or the coming week, the next day or week, as the case is with weather forecasts, or whether it's the next growing or dry season, as in the case of seasonal forecast, or years and decades down the road, as is the case with climate projections. This knowledge and information equip our nation and society as a whole for success in managing environmental challenges and capitalizing on environmental opportunities. We've made remarkable strides in Earth observation since the launch of the first TIROS satellite more than 60 years ago, when it transmitted its blurry images of Earth for 2.5 months. These observations have become integral to our lives, and there is still much to learn and tremendously important benefits to be realized. The work of the agencies represented here today has been indispensable in enabling us to understand our environment, how it's changing, and what those changes mean for life on Earth. They've done so by developing new observing technologies and capabilities, as well as pioneering and supporting the use of these capabilities for science and applications purposes. And the work the private sector has brought forth has been innovative in developing ways of cost-effectively carrying those observations forward, providing data and information that deliver great benefit to society. This combined approach is important for continuing to develop new technological and scientific innovations, and for providing situational awareness needed to serve society in innovative and cost-effective ways. And finally, the engineering and science communities that develop these capabilities and ensure their value is realized need to be recognized and sustained, as this committee certainly has and does. Some of that community exists at universities like my own, some at federal and federally supported facilities, and others in the private sector and elsewhere. But regardless of where these talents reside, most share the simple fact that they were initially cultivated at the nation's colleges and universities. So while investments in the development and use of these capabilities are absolutely critical, investments in the education and training of those who transform these visions and aspirations into society-serving realities is crucial as well. Environmental intelligence, as former NOAA Administrator Dr. Kathy Sullivan used to refer to it, positions our nation and society for success in the face of whatever lies ahead. The space-based observations ultimately deliver that intelligence and associated insights in ways that greatly serve the citizens of this country and the citizens of the world. I thank you for your time and your attention on this very important matter, and I apologize for reading from a computer, but my written remarks are actually sitting in a taxi somewhere that brought me here. So I'm going to close this now, and we can talk, but I wanted to get it right, so thank you.
Thank you, Dr. Abdulati, and I was impressed that you were using, not killing trees like the rest of us. Appreciate that. I now turn it over to our Chair Cantwell, who is an expert in her own right in not just technology, but in aerospace
well,
and imaging.
thank you, Mr. Chairman, and thank you and to Senator Lummis for holding this important hearing, and to our witnesses, adding a lot of insight and valuable information about the success and opportunities for us in this area. We know that the unmatched scientific legacy of the U.S. Geological Survey's Landsat program and the key partnerships that they've had with NASA have been successful. And of course, NASA being in the news now with the landmark Artemis 1 mission, which just reached a point at almost 270,000 miles from Earth, farther than any other human-related spacecraft. I'd like to start by congratulating them, NASA and the Artemis program, as well as the workforce in my state and across the nation who participated in this. With 42 Washington companies contributing components for Artemis, our state remains an aerospace leader, and NASA is keeping the United States in a world leadership position here as well. NASA, of course, does a lot more than explore space, and since its founding, it's had a mission to help us understand Earth, a mission shared by the USGS and the National Oceanic and Atmospheric Administration. And for over 50 years, these agencies have been working with their academic and commercial partners and given the U.S. a leadership role in developing and deploying satellite-based remote sensing systems for monitoring the Earth. Now, I can't tell you how important we feel this is today. In the case of Landsat, publicly available data yielded over $2 billion in annual benefits to U.S. users and over $1 billion in annual benefits to users outside the United States. The total global Earth observation commercial market is projected to be almost $8 billion by 2030. You may have gone over all this data. Okay, but this data, these services, this market represents sustained growth and opportunities, particularly in areas like agriculture to crop insurance to urban planning, and a very important subject for us in the Northwest and my colleagues here on this committee, wildfires. In Washington, the data and processes of information by NOAA Western Regional Center in Seattle, which houses offices for the National Weather Service and National Environmental Satellite Data and Information Services, data from these offices are invaluable in helping us cope with these increasing wildfires. During this season, and my colleagues I know in Western states saw this, an unbelievable increase in these instances. For example, the Bolt Creek fire burned approximately 15,000 acres on the east of Seattle in King County. We're used to having these fires on the other side of the Cascades, on the east side of the Cascades. We're not so used to having them on the west side of the Cascades. And Earth observation data were essential for real-time fire mapping, measurement, part of suppression, and assessing post-hazard burns. This is incredibly important because in this particular area, it's very steep and it's one of our 2 highway passes across the Cascades. And without that data and information or that highway, it becomes very precarious. So looking forward, we know that there is going to be a growing need around wildland fire prediction and long-term adaptation. We must be vigilant about these fires, and residents who just suffered through the Bolt Creek fires have to worry now about landslides, which is why all of this information, as those of you who are involved in this already know, that kind of fire damage leaves you very, very vulnerable. So the United States must continue to sustain its growth in Earth observation capabilities in alignment with our community needs and scientific consensus. And the symbolic development of research and operational capabilities managed by NASA, NOAA, and USGS will, I believe, remain very critical to how the partners in the private sector also develop. So I look forward to having an opportunity, Mr. Chairman. Don't want to get ahead of you and Senator Lummis on questions, but thank you to the witnesses and thank you for holding the hearing.
Madam Chair, I think you're probably, your schedule, I can only imagine today, so if you would like to go first with questions, I think that's all right with me.
Absolutely.
Ranking Member Lummis
Okay.
concurs.
Okay, so to our, Dr. Voles, thank you for being here virtually, I guess. I wanted to, could you speak how infrastructure funding that was part of the bipartisan infrastructure law, Fire Ready Nation Act of 2020 to strengthen NOAA's fire weather service capabilities are helping us with the fire and keeping residents safe? And what else do you think we need to do to help expand this capacity within NOAA?
Thank you, ma'am, for the question. It's an excellent question, and we definitely appreciate the disaster supplemental funds, which provided the resources to us. So with those particular funds in the supplemental, we have been able to accelerate the delivery, the development and delivery of some fire products, which take the information we get from our geostationary satellite GOES-R, and modeling and working with our National Weather Service with modeling to make a better use of those products to the fire emergency managers, but also into such services as our high-resolution rapid refresh model, which allows us to forecast the propagation of smoke and other effects that are coincident with the fire. These are products that were in the pipeline that we know we're ready to do, but where resource limited, we were able to accelerate them, for example, with the inclusion of these disaster supplemental funds. Looking forward, we definitely have seen the increase in the fire events, and our next generation, we have a number of other products which we're continuing to improve, but in the next generation geostationary satellite, for example, the GeoXO, we have particularly targeted bands which are better focused on fire initiation and have increased the resolution on those so that we'll be able to spot smaller fires faster and then give fire emergency managers a quicker response time to those fires. And one of the amazing facts in my mind was that we are able to contain roughly 97% of the fires that occur, but those 3% we don't contain within the first hours are the ones that lead to the bulk of the damage around the country. So if we can even improve that by 1%, we can significantly reduce the impact of major fires in the West and elsewhere in the U.S.
So what do we need to do to execute on that from a satellite perspective?
Well, continuing the development of the products and services, we're using the supplemental funds, but also GeoXO is now, it's in our program. It is not confirmed yet. It is ready for the next step, and we're actually taking it to the Department of Commerce in the next 2 weeks for the next step in initiation, and we hope to be able to, it will require funding for the first launch will be in 2032, and we'll take the time between now and then to develop those satellites and to prepare the weather service and all of the whole ecosystem, as Dr. Abdulati said, of managers and responders to deal with the increased data when we get it. It is important that we get the investments to supplement and to deliver the next generation of enhanced observations that will meet the growing need.
Well, this doesn't, I mean, I know, look, there's a lot of satellite use and a lot of interest that people have, but in this case, we get from the Weather Service usually by May, and then maybe an update later in the summer, this is where the hot spots are going to be. They already have their projections. Here's who's really going to be at the brunt of this, with weather forecasts. So sometimes it might be Wyoming, and it might be Colorado, and sometimes it's Washington and Oregon, and even, you can get a map that's very red in Alaska, and you're thinking, how can this be? But I know that my colleagues from Alaska can tell you it's real. They've had fires up there they never predicted. So at that time, we would then dedicate satellite monitoring to say whatever those hot spots would be for a period of, a month, 2 months? So we literally would be calling out, these fires. Describe what it is that we would do. I stumped our witness. I think they got.
He might have gotten frozen.
Yeah. There you go. Can you hear us, Dr. Voles?
I can hear you now. I'm sorry, you froze for just a second. So yes, I hear you.
Okay, my question was, we need satellite capability to target certain areas for like months at a time, I guess is the question.
No, I would say that's a misrepresentation. The geostationary satellites are observing all the time, 24/7 with no interruption. You mentioned the forecasting for a seasonal and the like, and that we don't change our satellite assets to observe those differently based on high vulnerability versus low vulnerability, but it allows the communities to pre-position, to prepare emergency responses to those areas that may be listed as higher vulnerability. What we can do with improved forecasting, ecosystem forecasting, understanding the health, the vegetation health, the soil moisture content, the general ecosystem environmental factors, to give even more higher resolution and higher
better broadband.
Good thing we sent that money down the pipeline.
Well, Mr. Chairman, I will. I think the point here I would make if Dr. Voles was back with us is just, so there is no reason why we shouldn't do this. So this is going to save us money. The three of us know how much fire damage is costing us, and if you can prevent some of it by what we say are activities of hasty response, and if we can use our geosystem to do that, let's do it. So thank you, Mr. Chairman.
Thank you. And I think that is that sense of when you get to a fire soon enough, you dramatically transform the damage done. It is the one thing you learn, every governor in the West learns, is that if you can get there in that first few hours when it's smoldering before it breaks into a blaze, you've got a very good chance of controlling it. Let me switch a little bit. Dr. Calvin, how will NASA and the Earth Information Center, this is the new center that Bill Nelson talked about in 2021, coordinate with other federal agencies to address priorities, wildfires, but methane emissions, land use? So much of this, and I think you all could speak on this in terms of the great challenges to orchestrate and to integrate all the different sources of data. So speak to that if you can start.
Yeah, Thank you, and thank you for the question. I think what we all recognize is that there's increasing challenges. We've just been talking about wildfire, there's other agriculture and droughts, and we have a lot of information both at NASA and other federal agencies. And the idea behind the Earth Information Center is to bring that together and make that information accessible to people so that they can respond to the challenges they're seeing in their communities. And there are a lot of complementary sets of information all around the federal government. One of the prototypes that we're thinking of for the Earth Information Center is around greenhouse gas in monitoring and in measurement. And here there's an interagency working group that's been actively working together on how you can bring that data together. So how can you take the activity-based inventories produced by EPA and combine it with satellite-based observations from NASA and other ground and surface-based observations from other agencies and bring that all together to provide more complete information. And so we look forward to working with our federal partners to make that a reality.
Yeah, and I'm old enough, I think I'm the only person here that's old enough to remember when Landsat first delivered images, real images, before we'd seen it in movies. We had various art directors' perspective, what they thought that would look like, but it was so different when we saw it. And, it really is, to this day, one of the most, to remember back to how amazingly transformational it was in our consciousness. It's hard to imagine today. Mr. Jablonski, obviously there's been a rise in the commercial small sats, these constellations of small satellites, and a number of companies such as Maxar have demonstrated the ability to produce high resolution, very high resolution Earth observation data. What can small sats, if that's a word, it must be a word because it's written here. What can small sats with higher resolution imagers, how can they provide targeted observations over specific areas of interest? And what are some of what is an example of that?
Well, thanks, Senator. I think probably the best way to tee that up would be to describe the vast amount of data coming in from the commercial as well as government satellites and how that's being, dealt with to help decision makers take action on it in a fairly rapid fashion. So, for example, Maxar's satellites have 30-centimeter pixel size, so that anything with a larger than 30 centimeters in a frame becomes visible. That means we can not only see, but using artificial intelligence algorithms, count all the cars in a city in a single satellite pass, and do that in seconds because of the revolutions that we've had in cloud computing, as well as machine learning algorithms and artificial intelligence in recent years. It's been demonstrably, I think, very effective in matching that type of data with weather patterns, for example, to then help fight wildfires in the West. So not only understanding where the fires are, but when you overlay weather patterns and terrain and elevation and difficulty in road networks and where resources are, figure out the best way to rapidly minimize the damages and impacts that might be happening while keeping lives safe, because when people go out into the field, if they're on the wrong upslope and the wind changes, that's when you can have a loss of emergency responders' lives. So Maxar and other commercial providers collect massive amounts of the planet every day, millions and millions of square kilometers and terabytes and petabytes of data, and it's too much for any one human to get through. So getting that data into the right places, making it accessible through cloud-enabled environments, internet-enabled environments, so that the first responders in a command center in Wyoming or Colorado can get to that information quickly, and then overlay their decisions onto it is what we're working on.
Perfect. Dr. Abdelati, you have a great deal of experience working with NASA and NOAA. CU Boulder now has a research partnership with NOAA. Can you discuss the importance of interagency coordination to federally funded Earth observation missions and maybe a concise suggestion or two for improvement?
Well, certainly the coordination is absolutely critical because we have on, upstream of the effort is the development of the technologies, testing of the technologies, then deployment of the technologies to learn how to observe the parameters we need to observe. And then further downstream, as you see in the case of Landsat, for example, or the satellites that support weather forecasting. We have the use of those capabilities to advance science, to advance applications, to provide information that inform our day-to-day planning. So the spectrum of activities from discovery and discovering how to discover is at one end to the other end of using the information, turning that into something of direct value to people. So that doesn't happen with just NASA doing its part and then kicking it over to USGS or kicking it over to NOAA. There needs to be this reach across agencies, and it does exist, where at the user end of things, the more operational end of that continuum, the needs are articulated so that NASA further upstream can be working toward delivering something that can be of use. And at the same time, as new capabilities emerge and are being developed, the operational agencies need to be aware of what the potential is. So that integration is absolutely critical. And as far as improving it, I will say this, it works well in an interaction sense. Where I would suggest improvements is there are still things that fall through the cracks because NOAA, USGS has its mission, have their missions. NASA has its capabilities that it develops. And when the mission-centric perspective, as is appropriate, is exercised by the agencies, they're looking at, okay, what do I have to fulfill my mission? There are observations that need to be done, that need to be continued, that don't quite fit into the operational space, but have been developed and continue to be developed by NASA. And finding a way to keep those going, even though they support knowledge, they support understanding our planet and how it operates, don't necessarily map to the operational function of the agency. So some overarching entity that says, this is what the enterprise needs to carry out, I think would improve it.
Thank you. Ms. Lummis.
Thank you, Mr. Chairman. Dr. Calvin, one of the things that our committee's been focused on is the growing concern about orbital debris. Is there a threat posed to the Landsat program by growing amounts of orbital debris? Is this something you are focused on?
So at NASA, people think about this, and we agree that it's important to ensure that space is usable for years to come. Space debris and mega constellations are an issue that need to be addressed by U.S. leadership, and I think I can refer other colleagues within my agency for more information on that.
Thank you very much. Dr. Abdelati, being from the West, you know well the dangers of not only drought, but also some surprise flooding from snowpack melt. In Wyoming, we saw a lot of damage this spring around Yellowstone National Park, where we had surprisingly rapid snowmelt due to some unseasonably warm weather and rain simultaneously. And so are there ways that Landsat can help mitigate these sorts of disasters?
Well, the mitigation, what we can do is observe as they unfold. So we can mitigate the management of those kinds of disasters and preparation. And it's not just Landsat, it's other observations, because it requires understanding the potential for rain. You know, how much water is in the atmosphere, how much is going to fall out, how much snow, we call it snow water equivalent, is stored in the mountains. So you mentioned rain. Rain makes melt happen much faster. It's a much more efficient energy delivery system for melt. So it really requires the monitoring and forecasting of rainfall, temperature, the rate at which it'll occur, the topography, because the runoff of the water dictates or is a big driver in flooding as well. So all of those elements combined. Certainly Landsat is a component of it, but there's much more to be observed.
Thank you. Mr. Gallagher, as you know, Wyoming is rich in oil, gas, coal, uranium. It's my understanding that using images from Landsat, we were able to determine the subsurface composition of minerals and other deposits based on above-ground particles. Certainly it's true with uranium. We see that in Fremont County, Wyoming, as well as some other counties. How's the data collected by Landsat's program making our natural resource location and extraction more efficient, pinpointing it a little better?
Good, thank you for the question. So yes, it's true that the superficial geology, if you know the superficial geology, then it can tell you whether or not it's complementary for minerals and oil and gas. Landsat has some spectral bands that provide some certain information about the surface. More broadly at USGS, we have other sensors that can do that as well. So in my mission area, I partner with the Energy and Minerals mission area on a project we call Earth MRI. So we're flying airborne instrumentation that is electromagnetic data that lets us see us into the subsurface for the identification of critical minerals. So I just cite that as an example. There, as my colleague said, there are really multiple sensors that give you that kind of information both on the surface and subsurface, and Landsat has a role.
Thank you. Dr. Voles, are you still there? Can you hear me?
Yes, I can hear you fine, ma'am. Go ahead.
Great, thanks. I want to expand on a question that was asked earlier. Are there data sets that can be used to help us combat wildfires in real time? As Chairman Hickenlooper stated, you know, if we can catch them early enough, we can really contain the damage. And I'm curious about whether data sets can be used in that way.
What Dr. Abdullahi just said a few minutes ago. Sorry.
Yeah, we're getting a lot of feedback.
Sorry, I say yes.
Okay, good. You answered my question, and you yes, and then you referenced Dr. Abdullah's name. So I wonder if I might turn to him to elucidate a little bit.
Yeah, I'm sorry. Can you restate? You're asking if there are data sets that can be used?
can help us identify in real time wildfire potential or.
Oh, certainly. You know, and in fact, I personally, my neighborhood was destroyed by the Marshall Fire in Colorado. We lost 1,100 homes. Mine was not one of them. There was a lot of smoke damage. But personally, as we were evacuating, I with my daughter and my coughing dog, I just looked around at how dry the land was and felt the wind, you know, and so it's information on wind speeds, it's information on drought. Soil moisture is key because while it was a likely human-ignited fire, as most wildfires are, the conditions for it, the fuel for it, were in the dryness of the soil and the vegetation, the winds that just caused it to rip through the neighborhood, the area. So data sets are soil moisture, information on vegetation, so we understand its health, how dry it is. Is it kindling or is it, you know, green? Winds, precipitation, and all of these can be derived from, not solely or exclusively, but from satellite observations, as some of which were mentioned here. Landsat is a great element of that system, but there are also things like forecasting winds and understanding soil moisture and other data sets. So yes, it's an integration of capability.
Thank you. And can I ask one more quick question? Do I have time for that? Mr. Jablonski, is there a way the private sector can work with the public sector's data sets and information to provide even more information?
Thank you, Senator. Absolutely. For example, on a private sector satellite, WorldView 3, we have over 20 multispectral bands, including shortwave infrared sensors. And those shortwave infrared sensors can actually see through the smoke to determine the boundaries of a wildfire, where the hot spots are, and help the teams on the ground best determine. It can also tell you when you think you've got a fire out, where you still have localized hot spots that you might need to take care of or work on. And then Maxar and other commercial companies have weather desk type abilities. So for example, our weather prediction capabilities are used commercially, but can also be used by governments to determine crop health, to figure out economic indicators, and in areas like this, think about what a propagation pattern might look like in a localized area.
Thank you, panel. Really appreciate your testimony.
Great. Senator Blumenthal.
Thank you, Mr. Chairman. Appreciate all of you on the panel being with us today. My guess is that not a lot of Americans understand or appreciate the immense value of the work that Landsat and similar kinds of systems do for our country, not to mention the vast potential value that they can add in terms of our understanding of the planet and our efforts to save it. Connecticut's coastline, as you probably know, has a number of expansive estuaries like Long Island Sound that are teeming with flora and fauna, with other kinds of ecosystems that are threatened by global warming and human development, natural disasters, and more. Landsat has been instrumental in better understanding Connecticut's waterways. In 2018, the Interstate Environmental Commission studied hypoxia. As you know, there are zones lacking oxygen, indicating poor water quality in Long Island Sound, using Landsat data to help determine the contributing factors to that problem. And Landsat data has also been used to examine ocean conditions and so forth. My question has to do with how accessible this data is to ordinary Americans, to environmental groups, to the public in general. I think you may have touched on this, Dr. Calvin, in one of your answers to Senator Hickenlooper, but perhaps you could elaborate on how this data can be made more publicly available and accessible to people who are interested in it, like citizens groups, environmental advocates, and others, and I'd be interested in views that others may have on that same question.
Yeah, thank you for the question. So all of NASA's satellite observations are publicly available, but one of the things we're working on at NASA is making them more accessible. They're often large data sets and you need a lot of technical expertise. So some of the things we're doing is moving some of these to the cloud so that you don't need a supercomputer, and providing more trainings on the data, including some in Spanish language. And then when I was answering Senator Hickenlooper's question earlier, was about the Earth Information Center. So part of what we're doing is trying to make it more accessible to public. And just one example of a tool we have now, we have a sea level rise tool. So you can look at coastal cities around the US or around the world and see how much sea level has risen till now and how much it might rise in the future. And we're continually working to make sure our data sets are usable to people and accessible.
Others have comments? If not, Dr. Calvin, I'm interested in the work that you've done on food and water. Can you talk generally about what we're seeing and learning about water quality in the United States, quantity and quality of water?
So we're seeing changes in the water cycle in general, more heavy precipitation events, more droughts. And a lot of what we can see with NASA satellite observations, we can monitor and observe those changes. And so we've talked a little bit earlier today about how we can see things like soil moisture and better understand that. We have a satellite launching 2 weeks from today called the Surface Water and Ocean Topography Mission. And this will provide us the first global survey of water running through rivers and lakes. So any river larger than 100 meters in width. We'll be able to see that. And then for oceans, we'll get a better understanding of ocean circulation. And all of those things impact food. So a lot of water scarcity work is looking at how much water do we have available, which the Surface Water and Ocean Topography Mission will tell us. And then we also need to know how much water we need. And so some of the other satellites that NASA has that can give us information about irrigation needs and soil moisture would be important for that as well.
Do you expect that that kind of analysis and factual collection will indicate some solutions, some steps we ought to take?
The goal with NASA is to provide the information in an actionable way so that people can use that as their to inform their decision making. And so we will be working with stakeholders and users to understand what their questions are and provide information that's relevant to those.
Thank you. Thanks very much, Mr. Chairman.
Thank you. Now, I have a question, a couple questions more. I don't know, I suspect Ranking Member Lummis might have a question extra.
I do, but I know that they just scheduled a call to vote.
I know, but I think we can be like 10 minutes late.
Good, okay.
I think this is a unique, we have votes being scheduled that, against our will. Shouldn't say that. Why don't you go ahead and ask a question, then I'll ask a question.
Well, I'd like to explore, I thought it was fascinating to hear about the abilities of both government Landsat and satellite data and private sector satellite data being used almost simultaneously and in a complementary way on some significant weather events or fire events. And so I'd just like to explore just a little more, Mr. Gallagher and Mr. Jablonski, with who analyzes it? Let's say you have a significant hurricane off, the coast, or you're watching it develop, or some such observable event. How do you coordinate between private sector information and Department of Interior information specifically?
Thank you for the question, Senator. I'll speak quickly about the Landsat data itself. We refer to Landsat data as medium resolution. So a little more on that. A pixel is 30 meters by 30 meters. That's about the size of a baseball diamond. And so a Landsat scene, one image, is actually about 13,000 square miles. So it's medium resolution. You're seeing things at a scale of regional scale. Mm-hmm. So a lot of the commercial sources of data are much higher resolution. You heard our colleague here talking about sub-meter resolution for their imagery data. So when an event like that occurs, the data is very complementary because the Landsat data is looking at the regional patterns, denuding of the landscape, loss of shoreline erosion, or high wind that takes out green infrastructure and human-built infrastructure. The higher resolution data is fed to emergency responders who are responding on the scene for what is needed in terms of immediate responses. Landsat data is usually used for longer-term recovery. How people access the data in real time, we've done in recent months and years efforts to put all the Landsat data in the cloud and make it immediately accessible in that way. And we also serve it, of course, through USGS, a tool called Earth Explorer.
Thank you.
Just as an overlay on that, Senator, the government has been far-reaching in its efforts to get access to commercial resources and make them broadly accessible. The largest program is the Electro-Optical Commercial Layer Program with the National Reconnaissance Office, by which they spend significant amounts on commercial data. and license that data in such a way that it is then broadly accessible to all U.S. government personnel and for U.S. government type programs. It's a very taxpayer-friendly way to buy something once and propagate it throughout the entire ecosystem. Beyond that, then, the National Geospatial Intelligence Agency has a program called Global EGD, or Enhanced Geospatial Delivery, which started as a small program over a decade ago in Afghanistan about how do you get satellite data to people very quickly, that has now expanded to include worldwide reach. So from the time that satellites go overhead until that imagery, very high resolution imagery, is available to over hundreds of thousands of users across the federal government, it might be a matter of 10 to 30 minutes. And it's broadly accessible with a CAT card in the U.S. military. You can just log in and get access. NASA has access. NOAA has access. One estimate was that the federal government saved over $1 billion by making that data accessible to the Census Bureau as they were doing their work. So I think it's a very far-reaching, expansive way to make that information available, and strong support for those programs.
Thank you. Thank you, Mr. Chairman. Great.
Senator
great
Lummis,
hearing.
this is
Great.
Steve Volz.
Okay.
If I can make a comment on that. You brought the example up of hurricanes. I think that there is definitely complementarity between the very high resolution commercial sector and the moderate resolution, as Kevin Gallagher mentioned. But what is necessary is the preparation so that the information sources are planned in advance, the integration is done, the systems are compatible. And it goes back to the point I think that Dr. Abdulati was saying, is that we have a whole systems of observations, including commercial and federal, and making them interoperable in the right environment so that when the event does occur, a hurricane or a fire, you're not arguing about whose data. You're using an integrated system where the data are then seamlessly used. So it's not a question of going through the CAC as we just heard and getting the data, but knowing the data are available and it's seamless in terms of time and in scale. And that's where the operational system side works with the planning, the dry runs, and we do this on a regular basis, months in advance on an annual basis, so that we have all of the players in the loop for utilizing the best data for every application as they come forward. And that's what the collaboration really is key between the federal, the commercial, and the local partners.
Impressive. Thanks.
Yeah, and there are companies, a number of companies, Palantir comes to mind, but companies that can help pull all those data sets from disparate sources together and make them help facilitate that interoperability that I think we all agree is a necessity. My last question is just, and again, I still have at home my Landsat, the first book of imagery, I think it was 1974 it came out, and I just couldn't believe it. And I was, as I went and got my master's in Earth and Environmental Science, it became kind of my handbook in a funny way of how we could think about the Earth. Back then, we didn't call it climate change, we called it the greenhouse effect. But everyone knew it, and many of those early predictions back from the 1970s and 1980s and even the 1990s are being borne out in a frighteningly accurate way. I just thought we could run down and let each of you just say a minute about the ability, and if you have a suggestion, I'm always looking for action items, but the ability to see methane is something that's a hot topic right now. But it's not just methane, but the ability to really begin looking at this Earth as an organism that breathes and inhales and exhales, and what we need to do to be able to, part of this is communicate to the American public that this pollution is going to have real effects, but part of it is actually measuring it in such a way that we can respond to it. So I'll give you each 30 seconds or 40 seconds, because I think otherwise I am going to get shouted down by the powers that be. Anyway, let's start with, I guess we'll start with Dr. Volz, now that we have you back, and then we'll go to Dr. Calvin down the line. Be concise.
Thank you. In my 30 seconds, I would say it is really the integration of all of these. To understand how the Earth is breathing, you need to look at it in a multispectral, multi-factors way. And that's bringing the data together and having them interoperable. And we're doing that in moving all of our data systems, those records and the current observations, into a cloud-based format, so that we can bring these observations together, public and private, high resolution and low resolution, global, so that we can have that holistic understanding of the Earth. And that allows us to do that forecast modeling and to explain the environmental systems better. Thank you.
Great. Dr. Calvin?
Yeah, so we're also working towards bringing together multiple observations. So different satellites and instruments, they have different spatial resolution, different revisit rates, different gases that they can observe. And so bringing all that together and then continuing to innovate. So EMIT is an instrument installed on the International Space Station. Its primary science is around mineral dust, but the science team realized they could observe methane with it. And so they're now using it for that as well. And so thinking about how can we be innovative about how we measure and monitor.
Several times we've spoken about cloud-based activities, and Maxar moved approximately 120 petabytes of data fully into the Amazon cloud. So it's completely accessible and searchable, and algorithms can run over those entire data sets, which are a 20-year record of the planet. The next big change now is to take all of the other data sets and position them geographically in an area so that they can all be run with algorithms across the same data set. So taking 3D precision data registration techniques, taking multiple sources of data, all getting them into that cloud infrastructure so that then the data structures can be useful to do things like predict methane detection, to do all the things you want to do with it. So that's the next big revolution.
Great.
So Landsat has been this independent, unbiased witness for the last 50 years to all the changes that have taken place on Earth, from 4 billion people to almost 8 billion people, and all the changes associated with that. It's a marvelous time series data, and the next big revolution is to be able to mine data sets like that. First of all, maintain those data sets. So 50 years from now, we have 100 years of observation data. But also to mine that time series using artificial intelligence and machine learning to understand what happened before and how that brought us to today, and make projections about where that's going to take us in the future.
Great.
And I would say it requires that we continually look at all the relevant parameters of the Earth system. It isn't just watching it rain. It isn't just watching it flood. It's all the pieces of it, and integrate them. And doing so requires looking in parts of the electromagnetic spectrum that our eyes can't see. So it may not be something visible, but it's there. Water vapor is not something we really see, but understanding its content and quantity and movement is critical. So integrating all the parameters within the Earth system and observing in a sustained and continued way. And as far as communicating goes, I would just say make what is not visible to people visible. It's hard, as I said, to see water vapor, but there are animations, there are ways of depicting the moisture in the air that can really speak to people, and the agencies, I think, do a good job of that. We just need to continue to get it out there.
Great. Well, thank you all, and I apologize. I could sit here, obviously, for an hour and go nothing I like more than getting a little more granular on some of these issues, and having you all in one place it is exhilarating. So I have a number of other questions. I'm going to put them. You'll get them. Well, they'll get collected into the record. Thank you all for making the effort to come here, and Dr. Voles as well. I think that we are, and I feel this, that we are on the edge of actually getting to the ways that we can demonstrate what the reality is and what the rate of change is, which is what looking at these long-term data sets is so powerful. We can see changes in the rate of change. I think we can get to the point where we can mobilize not just our country, but the world, and really address some of these issues much more successfully than we have in the last few decades. So thank you for all your public service, private service and public service, and I look forward to working with you all together. Senators who wish to submit questions for the record, questions will be due December 15th, and look forward to seeing you all each again sooner than later. We're adjourned.